Hello, everyone, and welcome back from break. I hope that you got a break and that it was restful. And you're probably not feeling quite ready to be back yet, and I'm not sure I am either, but welcome back. We have a few more weeks of this unit that we just started before break about aquatic food production systems. This is what's coming up this week. We've got maximum sustainable yield is something you're going to learn about today. And you're going to be looking at harvesting whales, hunting whales, and the ethical questions that brings up and where you draw the line. I'm going to just start on that question today, and you're going to be doing some more research on that question over the next couple of weeks. This live class this week, we'll get together in small groups, and you'll be assigned a fishing method that's harmful to the environment. You'll do just some quick research on it in class and then share out with each other. And that is the plan. So today's goals: maximum sustainable yield, being able to talk about what that is and being able to calculate it. We'll do some practice with that today, and getting started thinking about ethical issues about whales in particular today, but marine mammals are what we're going to be focusing in on eventually in general. So to remind you what we did right before break, we learned about the tragedy of commons. We did that imaginary fishing activity where the more fish you took, the more trouble that population had bouncing back. The whole concept of the tragedy of the commons being that when we have a common resource, but we all act for our own individual good, we're going to deplete the resource and eventually hurt all of us. So to keep that in mind as we continue on, it's very applicable to fishing and fish populations. It's applicable to all kinds of other things as well. Water resources and pollution, any food resource, all these things are applicable to tragedy of the commons, even sitting in a traffic jam. But thinking about fish in particular for this unit, maybe pause this, take a moment to just look at this graph and see what you can get out of it, make some sense of it. But what you can see here on the x-axis is fishing effort, or basically how much you are fishing, increasing as we go to the right. On our y-axis, you have your yield, so that's how much fish you're actually catching. So you can see it makes sense. In the beginning, the more you're fishing, the more you're catching. That makes sense. But there comes a point when you're taking so many fish that those fish cannot continue to reproduce and can't continue to keep their population up, and you've started to damage the fish population. So there becomes a point when the more you fish, you start to get less and less as a yield. So the idea here is there's something called a maximum sustainable yield. That's what MSY stands for here, which is the most amount that you can fish without depleting that population in the long term. So if we can calculate the maximum sustainable yield for fish populations and other things, we can make a much better informed attempt at getting as much as we can out of that resource without depleting it. So the maximum sustainable yield, here's our definition. The largest yield or catch that can theoretically be taken from a species stock without permanently depleting the stock. So we can think about all kinds of resources when we think about maximum sustainable yield. Fishing is very common. We can think about how many trees we can harvest from a forest. We can think about the amount of water that we can take from an aquifer, from any water resource. So carrying capacity is something that if you were in the class last year, you should remember. You may all remember this from biology, perhaps. So if you think of the number of individuals in any population that can be supported by an environment in the long term, that's the carrying capacity. It depends on things that we call limiting factors. Limiting factors limit how big a population can be. So that might be like the amount of water that is available, that might be the amount of food that's available, predators, all kinds of things like that affect how large your carrying capacity is. So this is relevant in this case because maximum sustainable yield turns out to be about half of the carrying capacity. So if we know the carrying capacity of any population in an environment, we can calculate the maximum sustainable yield by just taking half of it. Now, in real life, it's pretty hard to determine the actual carrying capacity of a population. So instead, we'll often just look at annual growth. So if a population increases in a year by a certain amount, we figure that's the amount we can take without permanently depleting the population, and it could bounce back from that amount. For example, if 1,000 fish are born in every year, our maximum sustainable yield would be 1,000 fish. And really, I should say if our population grows by 1,000 fish, because maybe some of that many are born, but some die. I'll get back to that in a second. So this is just a graph to show you the same thing. If it grows by this much, this is kind of like our surplus, our extra. We can think of that amount as our sustainable yield. Okay, so this is another way to calculate maximum sustainable yield. Same idea, it's that extra amount. It's how much the population grows by, but now we're just starting to think about what are some of the reasons that a population might grow or lose some individuals. And what we want to look at is the overall growth. So we have annual growth and recruitment. That's just a fancy way of saying the individuals that join the population, whether that is through birth or whether that's through immigration. So that could be individuals coming from a different population to join this population. And we might have individuals leaving because they die, or emigration. Same thing, individuals leaving the population to go live somewhere else. So you just want to take all the reasons that the population is growing and subtract all the reasons that the population is falling to get how much that population is growing overall, and that's your maximum sustainable yield. So there's all kinds of different ways that we can measure this. It can be measured in how many individuals you have. It can be measured in the physical weight, the biomass of those individuals. It can be measured in energy, calories, lots of different ways. So the units for maximum sustainable yield might vary. So try some examples. Pause this, give this a try in your notes, and then I will give you an answer. Okay, so looking at this question, we are measuring trees or timber in meters cubed. So we know that the forest starts with 800,000 million. That's a lot of timber. We have a very large amount. That number actually doesn't even matter because all that matters is how much it's growing by each year. So we can actually ignore that number. We know that we're losing 50,000 cubic meters and we're gaining 200,000 cubic meters. So the difference between that is our maximum sustainable yield. So in other words, 150,000 cubic meters is our maximum sustainable yield. And I encourage you to write down this question and show your work in your notes so that when you come back to it later, it will make sense with some context. All right, give this one a try. Pause the video and then come back to check your answer. Okay, so we have 30 trout happily reproducing. That's graphic. I feel like I wrote this question myself. So they are making 13 adorable offspring. 4 individuals join the group from a separate population and 2 are eaten. So altogether we have 13 plus 4 joining. So we have 17 joining, but 2 are eaten by hungry alligators. So in fact, we have added 15 to our population. So our maximum sustainable yield in this case is 15. Go ahead and pause to try number 3. So this one is to remind you that the other way we can calculate maximum sustainable yield is that it's half of the carrying capacity. So in this case, our maximum sustainable yield would be 100 individuals. So that's all your examples. You should know, however, that maximum sustainable yield doesn't actually really work super well. It's kind of like the best that we've got. It's a good thing to calculate and aim for, but there's a lot of situations when it has not really worked out. It's because we often can't actually get a realistic population size. Also, who you're harvesting. If you imagine harvesting some fish, if you harvest all young fish or all old fish or all fish of reproductive age, it's going to be a different scenario for how well that population can bounce back. So there's aspects like that, as well as the fact that there are things outside our control that will affect the population as well, things like disease or natural disasters. So it's a great starting point, but it doesn't always work really well. Here's an example of when it did not work really well. This is the orange roughy, which is often given as an example for how maximum sustainable yield does not always work. This was off the coast of Australia. And you can see they started commercial fishing in 1990. You can see what immediately happens to the fish population. It goes down dramatically. In 3 years, it was cut in half. Then they set quotas. So they set limits based on the maximum sustainable yield. And you can see it slowed down the population loss. It got better, but it wasn't able to bounce back. And in fact, it kept going down. And this graph only goes to 2001, but they have not bounced back. The population of the orange roughy has not bounced back. So we've figured out since then that there's a few reasons for this. So one is our population count was possibly questionable. It was based on fishing records. We didn't actually sample the population. A big thing with this particular species is that they mature slowly and live a long time, which is going to affect how quickly they can bounce back. These fish can't even reproduce until their late 20s, and they can live up to 100 years. So very slow growing. They can't bounce back the way that many fish species can. So despite the fact that we tried maximum sustainable yield and limited fishing on this species, they still have not bounced back. Reproduction is irregular with them as well. Okay, so that's all on maximum sustainable yield. We're now going to shift gears and think about hunting of whales and other marine mammals as well. So there's a few questions for you, but you're basically going to start by thinking about the importance of whales in ecosystems, the roles that they play. Then you're going to read an article about commercial fishing in Japan and what Japan is doing with that. And then you're going to start to think about indigenous populations and their practices in whaling, and start to think of an opinion about where you draw that line, what is okay and what is not okay when it comes to whaling. And we're going to get deeper into this next week.